Potash Corp of Saskatchewan retained Rob Cullman Engineering, LLP, as prime consultant for the construction of a new hangar. The hangar is especially important based on a number of factors, including to provide a dedicated and customized home base for the STARS Shock Trauma Air Rescue Society Helicopter Emergency Air Medical Program, and a base for Potash Corp's flight department and maintenance of their corporate aircraft. The new hangar also allows Potash Corp passengers to plane and deplane within the comfort of a secure, customized hangar. Some of the engineering challenges and successes included integration of a cost-effective, pre-engineered building and a 3-story office under the same roofline. A high-expansion foam fire suppression system for the protection of high-valued aircraft and helicopters. A backup generator to ensure uninterrupted operation for the STARS program. Efficiently heating the larger hangar while still maintaining comfortable levels within the office areas. This was a somewhat novel application of conventional technology and engineering practices. The project incorporates some complex mechanical and electrical systems that are specific to the main use of the building. WSP Canada Incorporated was engaged to provide full engineering services to return the 4th floor of the 1961 hospital wing back to its original purpose as an acute care patient unit. The development occurred in an existing space with limitations on infrastructure and 24-hour acute care units operating above and below the floor. The team designed 18 modern-sized patient rooms with patient lifts and individual washrooms. Through a teaming approach, the owner, contractor, designers, and hospital staff met a 14-month schedule for a project that would normally take 24 months using conventional processes. AECOM provided comprehensive engineering services to Water West Pipeline Utility, which included primary detailed design, tendering, construction administration and inspection, and an environmental assessment. This project was a unique and challenging assignment from an engineering perspective in many ways. It is very uncommon to design a municipal raw water pumping system where water is delivered over 55 kilometers before it is treated. Further challenges were the system hydraulics, which involved lifting the water from the South Saskatchewan River 110-meter vertical elevation out of the river valley, then crossing Richardson's Coulee 110-meter drop, and pumping at extremely high pressures over such a long distance for municipal water delivery. AECOM incorporated the use of all existing 55 kilometers of pre-existing cement mortar-lined steel pipeline, which was installed in 1964. It enhanced the pumping station by twinning segments of pipeline and replaced existing pumping stations with state-of-the-art modern pumping stations at Snipe Lake and CN Reservoir. The overall capital budget did not permit Water West Pipeline Utility to provide the ultimate flow rate to the town of Kindersley. To mitigate this, AECOM designed a raw water reservoir to store a large volume of water to supplement the flow coming from the river by the way of the upgraded pumping station. The Kindersley water plant was upgraded to include a new clarification and ultraviolet disinfection system. These upgrades were all completed while maintaining the water supply to Kindersley and Eston during the construction. The northern village of Denair Beach in northeastern Saskatchewan on the shores of ACEC Lake faced a pressing need to improve its wastewater treatment plant. The growing population had surpassed the design capacity of the aging facility, and the community needed to meet more stringent environmental regulations for wastewater effluent. Operating well beyond its life expectancy, the plant faced potential catastrophic process failure, and the mechanical and electrical systems needed replacement. The Council and Administration of Denair Beach, working with the Sask Water Project Manager and utilizing Northern Municipal Trust account funding, engaged Associated Engineering as the prime consultant to provide concept options, detailed design, tender, and construction services. Careful study determined that a sequencing batch reactor process would be the optimum replacement system. This process allowed for reuse of much of the existing facility with residual value. This choice of design was based on lower costs, better treatment capability, and ease of both operation and integration. Design and construction requirements ensured the continuation of sewage treatment throughout the renovations. The $5.2 million project commenced in March 2011 and was completed in November 2012. The AE team worked cooperatively with the community, regulators, and constructors to keep the project on schedule. Working with project constraints imposed by the natural ground conditions, the existing building, the sensitivity of the receiving water body, and the requirement to maintain service throughout the construction period added considerable complexity to the project. The result is improved effluent quality that exceeds all effluent quality requirements by a substantial margin, satisfying this picturesque community's needs and helping to preserve the pristine downstream environment. The town of Pilot Butte is a rapidly growing community of 2,500 residents that had previously relied on individual private wells for its water supply. Regulators were concerned with the health risks of untreated private wells and the lack of firefighting capability and would not allow further development without a centralized water system. BCL was hired to oversee the engineering, design, and construction services for a centralized water system to provide safe, high-quality water to every residence. 6 years later, 9 separate construction projects have been completed to support the new central water system. Each residence is supplied with water treated to the highest standard, and the town has a system with firefighting capability. Completion of the system has allowed Pilot Butte's growth and development to continue, resulting in increased property values. It has also reduced insurance premiums and the potential for harm to life and property. This project is being recognized for its uniqueness and its success at completion. It involved the complete design and multiple construction sites within an existing urban community. It also had to address the resultant implications of the town's sewage system. Considerable effort was required to identify and address potential construction conflicts and geotechnical problems. In addition, retrofitting service connections to existing buildings would have been a significant logistical challenge. Attention to detail was noted, such as the new plant's energy-efficient building, which will keep future costs down. The project has not only improved the quality of life in Pilot Butte, but has also set the standard for development in the region. SAL Engineering provided consulting engineering services for the Dundurn Rural Water Utility Phase 3 Potable Waterline Project. The project provided potable water service to the town of Dundurn, town of Hanley, Blackstrap Provincial Park, and 773 rural subscribers in the South Corman Park, Dundurn, and Hanley areas. The project consisted of approximately 345 kilometers of high-density polyethylene pipe, 5 pump houses, and other necessary waterline infrastructure. SAL Engineering's role was to plan and establish the routing of the waterline, analyze the system with a flow model, as well as provide project design, management, and site services. Subconsultants included Brownlee Beaton Creaky Limited, Wilms Engineering Limited, Key West Engineering Limited, P. Macabroda Engineering Limited, and Golder Associates Limited. Stantec is the owner's engineer, community planner, and project manager for the Global Transportation Hub, or GTH. They've been involved since the early stages of development, preparing concept plans, modeling all elements of municipal infrastructure, coordinating utility works, acting as project manager for construction, assisting with the legislative process for creation of the approving authority status, developing asset management budgets, and coordinating public work operations. As a greenfield project, the GTH afforded an opportunity to engineer a development founded on best design practices and futuristic standards. This is demonstrated in the scope of the studies and planning that preceded design and the selection of design parameters that reflect current and future needs as well as potential risks. Special recognition for this project is recommended because of its unique features. Not only did the consultant coordinate with all stakeholders and design and supervise construction, but they went on to develop the administrative aspects of the project once the construction was completed. This is unique because usually a project is undertaken within established development plans and bylaws. The Saskatchewan Ministry of Highways and Infrastructure is undertaking improvements along the Trans-Canada Highway corridor east of Regina. These improvements will address growing road safety and operational concerns for commuters leaving and returning to satellite communities. This part of the province has the largest rural traffic volumes and is the focus of much anticipated residential and commercial development for the foreseeable future. Tetra Tech was retained to identify the future interchange requirements for the main access to the town of Pilot Butte. The primary recommendation was to consider an innovative design that met stakeholder and ministry requirements through a collaborative process. A sound functional planning study requires identification and evaluation of needs and risks, and options to address those needs while minimizing risks.